Well, good morning, folks, and welcome to day 2. And thank you for getting here. I'm beating the traffic and commute and everything else. So let's get going. So I'm going to tell you a fairy tale about some Java serialization. Well, in good fairy tale style, there's always this like a seed of truth, and of course it goes back quite a ways. So we're going to just visit some bits and pieces. So who am I? I work in the support team at IBM, so if you've dealt with, talked to us with Java-based things or sort of thing, you've got to somebody probably like myself or one of my colleagues to try and help you out, diagnose what's going on, maybe if there's a real problem there, to actually develop a fix. I myself, we play with lots of modern programming languages, and there's a few more besides that. But I'm also involved with working out the whole support and logistics and the experience of it, and occasionally I get sent off to come on site and all that type of stuff. So that's sort of who I am. I've been doing that for about 20 years, which, but in that context, that means that when I started my Java support work, that was back in the days of about 1.22, and Java 1.3.1 was sort of like the breaking Java at that particular stage. So I've been with that Java journey for a fair amount of time, so there's a good chance that if you've dealt with IBM and you've dealt with Java, you might have dealt with me at some stage. Okay, so Java serialization. What we're going to talk about today. Well, this is not really the talk to tell you how to do Java serialization, because it's been around for a long time. That's why it's a bit of a fairy tale, because it's going to be a familiar story to most of you, right? But the thing about that is, I mean, over the years, it's very ubiquitous, it's very commonly used, but essentially, we've basically discovered, and it's pretty well known now, that it's facially flawed. It's not quite perfect. And the problem really is not what it's good at doing, it's what it also allows to be done against you. And that's really where this sort of talk is going. And we're going to try and look really at how they're going about that, and what, in some sense, the bad guys are potentially going to, how they can get in there and actually look at it. And that's where we're sort of going to go. So that gives you a flavor of what we're looking at, and hopefully what we're going to cover through the whole session. So what is Java serialization? What's it there for? Well, you're going to be familiar with the idea. We've basically got a set of objects that we create in one Java process, and we want to pass it into another one for it to be utilized there, because it's, that's how distributed computing kind of works. It may or may not be running at the same time. It may or may not be local to you. You might be using it through persistence. You might be storing those objects and recreating it later. But that's the basic idea, right? Transfer data from one system to another. That's when we need it, right? And so in some sense, it crops up in lots of places, right? It can be used for persistence. That's whether or not it's actually into databases. RMI, of course, is fundamentally based on that. You're passing it around. Of course, RMI, the objective there is you're going to try and run code in another process. But in simple examples, it's so ubiquitous and so easy to do. It's really convenient in something like a cookie, right? We can just like store a bit of state, and it's easy and quick to do, and we can recover it, and we can deserialize it later, right, into in another time. So, who definitely knows they're doing Java serialization, right? Right? Good chunk of you, right? I mean, it's a facility that's been around forever. It's very reliable. It works, right? So for those who didn't put their hands up, do you know that you're definitely not going to be involved in serialization, all right? If you're not writing that code itself, have you actually deliberately chosen to opt out or not? I mean, it is very ubiquitous. So, I mean, it's very easy to find just like how widely used this is out there. Basically, if you wanted to do a search on object input stream across GitHub, you can find there's a gazillion places where this is being employed. Loads of places. And it's really easy to use, right? I mean, effectively all you've got, I mean, this is not the talk about how to go about it, but there's a marker, just simply setting a marker interface on your class, and you're saying, sign me up, I'm available, I can work with serialization, right? And it's not hard to go through the code of actually conducting the process of saving that state and restoring it later. Not a great and hard thing to do, right? And even if you didn't set that serialization, the actual, if you attempt to serialize something which hasn't got that marker interface set on it, the system's going to turn around and say, no, that's, you're not playing. So on the face of it, it looks pretty good. It's useful. It does what it says on the tin. It's easy to use. So what's the problem? Well, the problem is it does work, and it works pretty well. It's just that there can be a few side effects along the way. And it's the side effects, which is exactly what the bad guys are going to try and actually create that exploitation route, create that path to do something else. So, okay, so this is where we're going to maybe take a slightly different twist, perhaps on where you've seen this before. That sort of top class, we're going to have a look at that, and it's kind of become an example we're going to sort of use throughout the presentation a bit. So, very simple class. It's going to come on the data packet, which we're going to create on one side, pass it across to the other side. Nothing really novel. At the bottom there, we've got the bytecode stream that actually would be created in that process, which is therefore, if it was stored in your database, stored in your cookie, it's going to look a bit like that. On the wire, that's what it's going to look like. Well, it's not particularly very user-friendly, but there's lots of things there which in some sense, a good technology is. So it's a bit like, there's a strong specification out there that basically defines this. It's a bit like a class file in that sense, right? So there's various things about in telling the actual format of the wire, just what is going on. There's version information, so if the implementation changes, we can adjust to it. We're going to basically say there's an object coming, and there's things there which you can pick up probably from your hex, which of course identify the name of the classes which we're going to be dealing with. It's a UTF-8 string, so it's length delimited at the beginning there, so on and so forth, right? There's a serial version, which is probably the most interesting thing about this. Some flags. Our object has one field count in it, so there's a count of the field. That's good. There's an indicator which is basically saying that's where the L is in the actual on the right-hand side that says an object's coming. You'll be familiar to that because that's obviously how the JVM knows about some of the type information it's got. We've got the name of the field, you might recall, right? The name of our field in the original object was called hello. That's another UTF-8 field string, and so on, right? There's a string there which defines the type of data that's inside the packet that's coming down the wire. Some more flags. And we've got the value. The value of hello, which we're going to put in to our field called hello, right? It's not too hard, but at the same time, it's not very convenient from a presentation perspective. You're not used to being plugged in and having that data come down the wire at you. So from a presentation perspective, we're going to just use a table sort of to pick up on those bits and pieces. But that's basically what we looked at from that sort of data. Very good, right? The thing which in some sense does a lot of the secret sauce of that is the serial version ID. Again, there's a lot of material which goes about that, but fundamentally that's basically saying the shape of the data we're going to receive needs to match what's coming on the wire. There's a sense in which there's some validation going on there. So if our objects had a mismatch in terms of the number of fields, it would be reflected partly in the field count, but equally that's the identifier that's basically saying what shape of object we're prepared to work with and receive. So you'll find a lot of that's the standard class library will have set and defined field values. If you're generating your own code, then you'll probably know that you can actually let it be generated at that particular stage. But it's necessary to make that sort of both sides of the exchange work, which is good. So, and we've got in there the actual payload of what we're carrying. It's basically self-defining in terms of how we're going to have to set up the parsing on that byte stream to actually get back the data we're looking for. Looks all good, right? Yeah, and it is, right? So, I mean, once upon a time, we needed this ability to send data objects around. It works. It's good. It's useful. So what's the problem? Is there really a problem there at all? Well, in some sense, the problem is that this data stream is self-defining. So, okay, let's try and illustrate what's going on. So if I was able to perturb that set of bytes that we've been kicking around, and instead I change it so that instead of therefore having string data in there, I say replace it with a number, right? Give it a value. That's the sort of places where we'd expect that to have made an effect. I've sort of coloured it for you. Pump it into our code, and Good stuff. We've got an exception, right? It did not take it. And in this case, it didn't take it because, well, what we've tried to receive into our string, the data on the wire wasn't a string. And it basically picked that up and said, no, I'm not playing ball, but that's goodness. So, how safe do we feel, right? It's looking good, right? I mean, from the point of view of what we actually intended to do, there are some safety protections in there to preserve that functionality, okay? Okay, so this is the example. This is mostly what we'll be looking at from the point of view of the payload which we're looking at. But if instead of that string, I'd actually been sending around an object, well, as a receiver, it would all that we've talked about so far would still work. But just as I could have sent a string in that payload, I can now send all kinds of other things. I could send an array with some values, or a hash map. They're all objects. They will all be received quite happily into our field hello in that particular object. Anything will actually be consumed into that quite happily because objects are universal receiver in that sense. Now, you're getting a sense of why, in some sense, the self-defining stream can potentially be dangerous and why it can be subverted. It's all fine and dandy when we actually either want that flexibility ourselves or we create the opportunity for potentially other things to happen. And that's in some sense where the danger in some sense of this lies. Okay, so let's pick something else. I know it's early, so this is just a little start of attempt. Okay, this is a simple class. From our source side, if we run this class, what's going to happen? It's not very simple, not very hard, because in some sense we just put some simple print lines into some of the constructors, right? We're going to get the static initializer called, assuming we haven't actually, this is the first time it's been loaded, and we're going to get the constructor, the print line from our default constructor. That's not too hard so far, right? Good-o. Okay. If instead I'd now sort of pumped that object down our wire into our receiver, what do you think is going to happen then? So, okay, we've just, the same example we've just looked at. What do you reckon is going to happen here? So we have some hands. What about the static initializer? We're going to see that called? Yeah. What about the default constructor? We're going to get that called? Yeah. Maybe both, right? So we're going to see both. What about none of those? Oh, well, there's not that many hands. It's clearly before coffee, right? Okay. What's the answer? Oh, the static initializer was called, assuming that our class needed to be loaded on that receiving side, right? So we got the message coming out of the static initializer. And then we got this exception. We didn't get the message come out from our default constructor at all. Ah, right, okay. But we didn't receive the data. Assuming there had been data on our payload, of course there wasn't. That's a bit of a sort of fake. The thing about this, though, is that it's very specific. This is about actually transferring an instance into this particular situation. We didn't call that constructor actually at that particular point in time. But we got an effect. That's the side effect, an example thereof, right? Because despite the fact that that code didn't achieve that transfer process, we did induce an effect on that target system, and we got some code to run. And this is where, in some sense, it starts to build up. So, and this is what can become useful and used against us, especially in that situation whereby they want to not necessarily use the system at all to transfer a data object as you intended your system to be designed, but because they want to get an effect on your system, they're happy enough to induce and send a graph of objects of their choice if they could get this sort of chain of effects going. And the static initializer is just an example of that. Okay, well, maybe foo's a bit more complicated. On the source side, things are going to regularly happen here. We've got a default constructor. It's going to initialize some data for us. We're going to, as a method, it's a little bit more useful, more interesting. It's going to return length, right? So on the source side of things, when we'd call size, we'd get what we expect. We're going to get a value of sent down there. So I mean, even on the wire, it's going to look as we'd expect, pretty straightforward. On the receiving side, if we call size, is the answer going to be 4, or is it going to be something else? Actually, there's a sense in which if I can disturb that stream, and I didn't put the pre-initialized data value, if I put something else, like a null in there, what happens now? The constructor, as we just sort of like looked at through those examples, of our serialized object is not going to get called at all because we're just transferring the instance values into there. So if and when we call size on that target object in our, in the receiving instance of our program, we're now going to get a null punishment section instead. So even the code that we've got, there's a sense in which if all your validation logic is only in your constructors, and you pass that around, none of it's going to get called. And actually, whilst we've talked about opting in on those objects we deliberately expect to be passed around, the effect can go wider than that when we looked at the whole process of a graph of objects. The example we've had so far on the wire was, of course, extremely simple just for the benefit of this. But if instead we'd had some kind of inheritance structure, here we've got, again, some fairly simple methods going to provide some sort of output of what's going on, but there's not actually much in the way of data here, but it's a good example. Only in the subclass here is the object which we're going to actually pass across the wire. How many of these constructors are actually going to get called on the different ends? So, I mean, on the process here is that the writer of our parent at this particular point in the hierarchy hasn't necessarily agreed, you might say, to sign up to serialization. Not that they've prevented it either. But as a consequence of the subclassing process, we've just opted that code into this process. So on the left-hand side, if we were on our source JDK where we construct something, all those regular things happen, right? We're going to get all the constructors we called along the way. On the target, okay, well, we'll get a difference actually will come through here. The parent class loaders are going to get all loaded up as we expected, but the subclass constructor that we see isn't. So again, it comes back to this problem of where we can actually potentially trap or put in any of the validation logic to actually ensure that what you expect to get in your system, you actually are getting. To make it just clear, the subclass is just not called at all there. So the real question at this point, of course, is, in terms of the inheritance structure, did the author of our parent class in this, did they even expect to be part of this serialization story? Maybe they never believed that they would. Now, again, they didn't prevent themselves from opting out, but did they expect to be part of it? What about interfaces? Right? So interfaces, you expect to have to be subclassed. It's the inheritance of it, right? So at this particular point, right, there's no marker interface there, so unsurprisingly, none of this is looking particularly problematic at this particular point in time. But if actually, as a process of this, the designer of that interface later on decides that for whatever other use cases they've got, that it'll be useful just to actually serialize it, then in actual fact, just because you actually provided an implementation class unrelated, you've actually suddenly been opted in on that too. So it can go both ways up and down the inheritance hierarchy in this particular case, whereby you can get propagation of effect, where you can be sort of brought into the system unawares, unexpectedly. So, up until hopefully by this sort of stage, you're getting a bit of a face, a bit of a shape as to why, in some sense, this can be a bit of a gift to the bad guys. So we're particularly concerned with how security and so on. So hopefully you're all particularly up on keeping an eye on vulnerabilities out there and How regularly do you patch those sort of systems? How much, are there particular problems that the serialization has? Well, yes, there are. I mean, it's not very hard. So a very simple search of, where the industry, the databases in relation to these sort of things are, CVEs, critical vulnerability. There's multiple places like MITRE and stuff like that where you can come and search this. Now, throwing in quite a very specific search term, it wasn't hard to come up with a number of vulnerabilities which specifically identify serialization and Java to be there. There are many out there. And 24 is a lowball number in that particular respect just because of the specificity of how we probably searched for it in the first place. They most definitely exist and in any recent time. So at this particular stage, you might really be wondering, well, can we be safe at all? All right. Can you opt out? Can we actually sort of say, how easy is it to actually try and take more control? So, you can. You can definitely try and take some particular points, but the point is, what point can you intervene? So here's another sort of example of a potential pattern, and we've seen examples of this out there. We've got. We're exchanging sort of information in a system, as you might imagine, sort of like slightly orthogonal perhaps to the direct purpose of this, but it's going to be like a monitoring or logging type sort of framework. Now, we haven't talked about transient, but that effectively is basically saying there's something local in this file which isn't going to be relevant to Exchange, right? Because the point about that is you're going to have to set up that absolutely locally in your instance. Where you have your first point of sort of intervention of what you received off the wire is in the read object method, and in there you can therefore put in place some of those things whereby you can patch up the implementation to make it work on that local side of things. So in this case, you would, if your system has logging as a pattern across all the potential instances, you're going to need to patch up that ability to connect with a log file on a local system, and that, in some sense, would be where you'd do it. You could do it in a read object method at that particular stage, right? But in some sense, the data, the payload here, might just be simply identifying a log file, which, probably has something in your mind, in your design, is going to be something fairly innocuous, something that exists most places, temp/log. But in the same way that we could subvert that data stream, what would happen if a bad guy got in there and actually changed it? Into something more interesting to them. Because in some sense, if they can construct that sort of side effect whereby they may be adding another entry into your password file, or anything can be made to happen. Other ways. Well, you could try and trap that read object. Now, we've added a final in there to try and make that exception concrete. But in some sense, it's quite a fragile thing. It's very easy, even in the typo, to try and actually get that sort of wrong. I may have made the mistake myself, but in other words, you can actually, in some sense, get it to sort of try and actually trap that point. The problem is actually based on the signature of that particular method. It's very specific, and it's a private. And there's a sense in which you can't, therefore, you can't utilize it in a template that you can scale across a whole bunch of instances. You're going to have to go into there on every single instance and add that type of thing in. It's not a very nice way of actually dealing with that as a solution. Okay, well, I mean, in recent times, there is some systematic way you can try and help and address some of the potential downsides. So they, in around Java 9 timeframe, they come up with the whole serialization filter, and they backported this. So in some sense, they backported it to all the current in-release things. So that's Java 8, Java 7, and Java 6. And you can actually, therefore, try and actually set up at the instance level of the JDK to try and limit or constrain or some of these things. I'll let you can look this up. It's out there. It's a bit of a kludge. It's a bit of a, if all you've got is a hammer, it's a bit of a sledgehammer way to try and crack this, because sometimes it's not very specified per application instance. I mean, there obviously are ways you could actually transfer this down, but I mean, it's at least something, right? It's at least something, because there are all kinds of things out there to try and deal with. Actually, perhaps one of the best ways you could actually try and take control of the situation is to use your own version of the object input stream. Pierre wrote his particular paper a while back, but basically what it did is it's saying take control of actually walking that byte stream and utilize it as like a look ahead, and there's enough metadata in there, you can probably at least work out whether it's something you actually expect or want in your application at all. The downside is, of course, is that whilst that becomes your own specialized way of your own object stream in your application, there's lots of other people who are actually out there just utilizing the standard one, which is in some sense has all the safeties taken off. So, what else? Well, the point about, in some sense, the danger of this is that the biggest side effect and the biggest problem you have is it's enabling other people to potentially initiate code in your system that you weren't necessarily expecting or wasn't available. But it was presented, is available on the system because it's on the class path. Well, modularity, which of course has come in, can help to start to reduce that threat surface, simply because of the way the modularity is. That's exactly what it's trying to do for you. It's a help, but it's not going to fundamentally actually remove the major threat. But it's certainly definitely a way to reduce that sort of exposure. Other things you could try and do, well, you can actually, of course, try and take the code element out of the payloads. You can try and break it down so that all you have is just a payload of data. Yeah, it's slightly helpful, and if you're going down that particular route, then you don't even have to necessarily stay within a class that is only carrying data. You could, utilize JSON or whatever, but a lot of even the uses of JSON actually will still encourage you to potentially put type information in there, and that just recreates basically the same scenario again. It wasn't the protocol it wasn't the structure of the actual data in it. It was the very fact it was a self-defining data structure that gave you the data in the first place. So in some sense, just changing it into a different protocol didn't necessarily buy you anything because the fundamental problem is exactly the same. You could even try and utilize other alternatives to the inherent thing. So X streams, things like that. They effectively can support something of the same sort of serialization dangers themselves. So it's not even a great alternative. There's not a great panacea that's out there, unfortunately. It's pretty hard to actually defend against this. And the problem is it's not the intentional code that you wanted to write or the intention that you want to get when you're driving the functionality that you want to achieve. The problem is it's all the other code which you had to put on your class path because of all those useful frameworks, and it's all those dependencies, and it's knowing what they're doing or what they did or what choices they made, which may or not align with what you actually want at all. So, that's a bit of a summary of serialization at this point. So, in some sense, how do the bad guys go about, potentially orchestrating a track? How can they utilize some of these bits and pieces? So we looked at some of the data manipulation side of things. Well, one of the effects, in some sense, there can be numerous effects as to what they want to usefully do. But there are good examples out there of the denial of service attack. And that's incredibly easy to actually potentially execute on you. If we return to that example of the array, all we needed to do was give it a large enough instance count, perfectly valid, but when we receive that, on that receiver, now it's going to try and create this huge object. Well, it doesn't even necessarily have to be maxed in. That's there for effect and show. You can know what that's going to happen on causing that out of memory. But actually, if even something like as simple as like a containerized instance, that can be a very fine-grained trigger on your process size before you know that actually that instance can be like knocked out of action pretty straightforwardly. Or you might just be able to subvert this by causing a much larger object, a humongous object perhaps, and just starting to create effects into the garbage collection, which can, again, be a distortion. So not necessarily bringing the process to its knees. Okay, now let's get some really fun stuff. Who's heard of Gadget Chains? Yeah, just the one or two? Okay, this is really fun. So this is the sort of thing that a bad guy really wants to do. Right? So we start at the top with what we've now know and love as the basic mechanism of a read object. if we can sort of arrange a nice example of a chain, we can get all the way to the bottom and get runtime exec, in which case, all right, game over, right? We could, as a bad guy, all our options are available. Very unfortunate series of calls, but this is actually an example of what a gadget chain is looking up. It's looking to set up that kind of call chain, and it doesn't have to make sense through objects of your design. It just has to be objects that were available and presented on that class path. And if we can orchestrate a calling sequence and through a chain of side effects to call it, the world's our oyster. Okay, well that's hopefully pretty obscure, right? I mean, that must be hard to achieve, right? It's going to take a fair amount of work to do that. Well, that unfortunately is where Gadget Chains come in. Just as like developers, there's all kind of productivity tools out there to combine our resources and all the rest of it. Well, strangely enough, our friends, those penetration testers out there, have been putting together these sorts of things too. So this is a fairly well-known site. It was put together by a security researcher, and he basically has provided a set of gadget chains whereby there is this known set of exploits. Very simple. This is just an example of from the help of available there. He's basically packaged up a set of payloads that work against known collections of useful things that are widely out there. I mean, you can see the Jakarta Commons comes up quite a lot in that particular set. Hopefully nobody here will recognize some of those versions, because in actual fact, therefore, there is a pre-programmed, pre-made template of behavior that can cause a gadget chain which could affect some kind of calling chain, that was the previous example. But this is just the simple payloads in some sense of that help. The whole point is that in that database, they've collected a whole great set of those sorts of things. So is obscurity going to be your savior, right? Is that potentially, if it's not hard to actually create that kind of attack, maybe just by not being visible? Well, actually, there's other databases too, and none of these which we're talking about here are actually examples of what's on the dark web. This is all completely legitimate stuff that's wide and clear. This is Showdown.io, is a database which basically has probed all those sort of active places on the internet, and has worked out what protocols, what ports are open, and kind of identifies what's there. Sorry, I was going to give a wide example, but I'm not going to risk the demo gods in this particular case. But you can basically search for IP addresses out there which have open services, like RMI, which we've already discovered is the basis, has its basis in implementation in terms of serialization. And so in some sense, the bad guys can therefore find and discover by probing against IP addresses what's out there. And in fact, some of those systems are actually prepared to give up and give away a lot more information than we might like. So, a Jenkins instance in its headers actually identifies what version of Jenkins is running. Well, it's not that difficult to go and find CVEs that potentially connect and wire up to those particular versions, and you can start to get a feel and a shape for all those classes which can be known then to be present on the class path of those sort of instances. So from an exploit perspective, okay, there's databases out there which basically then provide those CVEs. And as I say, the exploit database provided that last example of the Jenkins instance is one of the exploits that's sort of in there. It provides guidance and tools, you might say, to even interrogate those sorts of things that search engines like Google have actually gone out and actually captured an awful lot of metadata about those systems, and it's not necessarily even the way you normally think about collecting information in regular searches. So there's actually quite an impressive amount of ways in which your system is giving up a lot more information about what you're running in such a way that you can be connected with all those public exploits. And so in some sense, that's part of the encouragement here is to recognize that actually our peers on the cybersecurity front are utilizing the same sort of ideas that in some sense have made us as effective as developers today. They are actually pooling their talents and their resources, and there's a lot of information out there making the tools and the collateral available to potentially take advantage of those vulnerabilities. So it's very much an encouragement to, you can't really sit on your laurels and not leave those systems unpatched. It really is a call to arms. Because the problem is that cybercrime is getting pretty significant on a scale. I mean, it catches the headlines, at least in terms of those big cases that you definitely don't want to be associated with. But just as an example, I mean, it was only in 2016 when, in actual fact, the estimates for the size of the cybercrime, of the size of that particular impact, was compared and comparable with that of the drug trade at that particular time. Well, it's not too hard to think about what is actually easier to prosecute. What is actually, if you actually really want to, pursue the nefarious sort of side of things, jurisdictions and all that type of thing make that, you don't even, you can make remote attacks, it's all kinds of things. It's very much easier to see which is more likely to be the growth area. So this was the kind of shape of predictions of the scale and size of cybercrime. So the green line there is the drug trade, which in some sense has lots of physical aspects of its problems. But the growth in the cybercrime area, at least is of that sort of shape. Whether the actual values are quite right, you can debate that because, of course, it's a bit harder to work it out. But to put that in context, basically, you could say the cost is being borne by all of us. And just because of that sort of disproportion of the impact on the developing world, you can basically say, whilst the average is reasonably worrying, the very fact is, if you pick any developed nation, we're going to bear the brunt of that even more. So in some sense, it's coming quite near to home. It's a bit like that the social responsibility aspect that Chris was talking about. There's a sense in which we're all going to bear the price for this, whether or not we're directly impacted or not, because that money is in that side of the dark economy is happening somewhere. The other thing is to be aware of is in some senses that we represent one of some of the biggest sort of targets in this particular system. Because if you think back to the first keynote, a lot of what we talked about here is about trust, right? The whole point about that self-defining data serialization format is we can be very trusting in receiving that data. And the real question is, should we be so trusting, right? But the other thing is you hold the keys to the kingdom of so much of that IT infrastructure out there. So that, in actual fact, you are invariably the sort of candidates who actually, the bad guys will use social engineering against you too. It's very easy, and we've probably all done this. It's very easy to actually sort of like tackle something of this sort of thing. I mean, have you ever done any of this? Probably have. In fact, it's a bit scary to think that there's plenty of code out there which looks a bit like this. Okay, we wouldn't have to take any confessions at that particular stage, or you can speak to me later, but we've pretty much all done something like that. I mean, it's effectively, we're all information workers, it's kind of the tools which we all have today, right? Everyone does it. How bad can it be? Well, actually, if you did a similar search for like Trust Manager in GitHub, there's loads of instances out there. So it's something which we're tackling, it's on a fairly big scale. So Java serialization, we've discussed, it is useful, right? But the problem is we don't want you to be unaware of what's going on. And there are things you can do, and really, we want to encourage you basically not to leave yourself wide open. It's very hard to escape, right? There's just simply so much code that's out there, and the problem is not what you can do on your patch, it's how much trust you're putting into your other peer developers, and that's in some sense, of course, is picking up open source. You just could be a little bit aware of actually what's going on in that particular space. At the end of the day, the bad guys are out there to really exploit what you don't know. So the whole point of this, and I really appreciate you being here, is because we're just trying to remove the veil of that sort of ignorance, right? To bring attention to this sort of subject. It's not about what you intended to happen in your system, it's what you made possible in that system. And that's, in some senses, what we tried to give sort of an example to here. And for that, I want to thank you. For those, in some sense, October just happens to be that time of the year where around the world, whether it's the US or Europe, there's a bigger focus on security. Not that we cannot be focused on security all the time. And just in the same way that we're encouraged to take our 5 fruits and vegetables, here today you've actually been exposed to 2 of the top 10 from the OWASP thing: insecurity with serialization and utilizing other people's code effectively. So thank you very much, and I'll let you get on to coffee.